The steel girder shuddered as the massive bow section clanged into place, and for a moment, the yard fell silent. Men held their breath, rivet guns paused mid-swing, and even the cranes seemed to hang in suspension. Then, as though a starting pistol had cracked through the air, welding arcs blazed back to life and hammers struck steel in a thunderous chorus. This was not the measured, months-long ballet of traditional shipyards. It was something else entirely. It was a revolution in motion. Imagine the shock on faces accustomed to 6-month build times when, in just 4 days and 15 hours, a full Liberty ship slid gracefully into San Francisco Bay. That extraordinary moment on November 12, 1942, didn't happen by luck. It was the product of audacious decisions, bold reengineering, and the conviction that conventional wisdom could be turned upside down. Contrast that with the old methods. Master shipwrights painstakingly drilling and hammering 1,000,000 rivets, each pin requiring precise coordination, each plate aligned by eye and hand. Skilled crews, years into multi-year apprenticeships, passed trade secrets down through generations like family heirlooms. It was craftsmanship of the highest order, but also glacially slow. And in a war where German U-boats devoured Allied tonnage faster than ships could roll off traditional ways, glacial would not suffice. Enter Henry J. Kaiser, a dam builder with no pedigree in shipbuilding but an engineer's mind tuned to scale and speed. He saw the shipyard not as a guild's refuge but as a factory on the mudflats. He understood that if the line speeds could match Ford's assembly plants, then ships would no longer be measured in months but in days. Yet his proposal met avalanche-sized skepticism. Rivets were reliable, welding was unproven. Britain forbade it on warships. The U.S. Maritime Commission feared brittle fractures would send hulls to the ocean floor. But desperation carved cracks into doubt. In 1941 alone, 3.6 million tons of Allied shipping sank. At 230 days per ship, the math was grim. The Atlantic would be lost long before replacement tonnage arrived. Necessity demanded a wager on innovation. Kaiser's gamble was twofold: overhaul the plant layout into parallel prefabrication zones, and eliminate rivets in favor of electric arc welding. Open prefab spaces, 7 assembly ways, overhead cranes every 100 feet. Pipe fitters, farmers, housewives welding bulkheads they'd learned to join in 2 weeks. Clay Bedford, Kaiser's chief engineer, returned from a Ford visit convinced that entire ship sections could glide down on rails instead of inching forward plate by plate. The first schedule still creaked, 197 days to launch the inaugural hull, yet each successive vessel shaved weeks off that time. By spring 1942, they averaged 70 days. Traditional yards watched, aghast, as semi-trained crews blurred the line between novice and master. Then came the stunts. Oregon knocked out a Liberty in 10 days. Richmond answered with the SS Robert E. Peary in under 5. Behind those headline-grabbing feats lay rigorous planning. Bow modules with anchor gear, steering sections, engine rooms, cargo holds, all fully outfitted before keel block placement. While one crew welded hull seams, another built boilers and crane carriages. When it was time, heavy-lift cranes dropped engine assemblies into their beds in hours. Execution replaced tradition. And when the Peary settled into San Francisco Bay in 4 days, 15 hours, and 29 minutes, history shifted. Admirals who once scoffed now ordered every yard to copy Kaiser's methods. This wasn't theater. It saved lives. Each Liberty carried tanks, jeeps, ammunition. Every day gained was cargo delivered before wolves beneath the waves could strike. Yet the story extends beyond wartime urgency. It's about reimagining what factories, governments, even societies deem possible. Kaiser didn't just build ships. He built a new industrial paradigm of prefabrication, simplified specs, and rapid skill training. Principles that echo in every modern shipyard and high-volume manufacturer worldwide. The lesson resonates today. When urgency collides with imagination, constraints dissolve and the impossible becomes routine. The clang of steel and hiss of welding torches reverberated through the Richmond yard as the workforce, young and old, skilled and green, moved with synchronized precision. Picture a wave of activity spreading across open yards. Beams lifted, sections aligned, bulkheads joined. Each worker held a piece of a puzzle that transformed raw steel into a vessel capable of crossing oceans. But this orchestration wasn't spontaneous. It was choreographed through meticulous planning and aggressive scheduling. Kaiser's secret weapon wasn't just machinery. It was psychology. He tapped into a competitive spirit, pitting yards against each other in informal races. Richmond versus Portland, East Coast versus West Coast, it didn't matter. Daily updates in newspapers turned shipbuilding into spectator sport. Workers didn't just build ships. They built pride, each assembly line becoming a test of human resolve. Contrast this with the isolated silence of older yards, where one mistake could halt progress until an expert arrived to troubleshoot. There, the fear of failure maintained caution but throttled speed. At Kaiser yards, failure was a step in the learning curve. Welders learned to adapt on the fly, spotting inconsistencies in steel temper and modifying technique. Foremen encouraged experimentation within boundaries. This fail-fast, learn-faster ethos drained the terror from risk-taking and replaced it with collective ambition. Under this culture, a secretary-turned-welder and a farmhand turned crane operator realized that their contributions mattered as much as any master craftsman's. With hands trained in days rather than years, entire assemblies took shape in parallel workshops. The engine room, once the most cramped and complex space in a traditional yard, was liberated onto rails. There, specialists fitted piping and tested turbines in open air before sliding the unit into the hull. By decoupling subsystems, Kaiser dismantled the sequence constraint that had chained yards to linear progress. It was a radical reframing. Shipbuilding transformed from an artisanal process to an industrial symphony. As production accelerated, statistical charts in office windows told stories more dramatic than any other front. The average build time dropped from 230 days to 128, then to 97, and finally to that watershed moment of 70 days. Traditionalists scoffed at toy ships, but cargo tonnage spoke louder than derision. Every liberty delivered meant food, fuel, and munitions reaching desperate fronts. German commanders could not outpace American tonnage. Each day shaved off construction created ripples through Allied strategy. And as the U.S. launched 3 Liberty ships daily by mid-1943, the Battle of the Atlantic tilted toward victory. Beyond yards, Kaiser's principles rippled through suppliers. Steel mills erected near shipyards to shorten delivery times. Fabricators pre-staged sections in adjacent lots. Even railroad logistics adapted, running special trains to shuttle components on synchronized schedules. This end-to-end integration mirrored the efficiency of automobile production but on a gargantuan scale. Historians later likened it to a living organism, each part attuned to the pulse of war. Yet the most profound transformation was social. Kaiser invited women and minorities into roles once barred by tradition. On any shift, welders' masks hid both experienced hands and novices fresh from 2 weeks of instruction. The line between professional and amateur vanished. This integration reshaped American industry long after victory in Europe. Post-war shipyards, automotive plants, and factories adopted modular prefabrication and targeted training programs. Kaiser's wartime emergency became peacetime standard, elevating productivity and broadening opportunity. When historians look back, they see not just ships but a paradigm shift in industrial organization. And it all began with a civilian willing to challenge centuries-old conventions. Today, our factories, our logistical networks, and even our software development pipelines follow echoes of Kaiser's approach. We call it agile, modular design, or parallel workflows. But the blueprint was drawn in Richmond's mudflats. The question that remains isn't how one yard built ships in days, but why we ever believed months were necessary. That realization dawns 4 days after you drop a section into place, when the hull holds together under its own weight, when engines roar to life, when a vessel slides into water amid cheers instead of doubts. It's the moment you grasp that constraints are mental constructs and breakthroughs lie in reframing problems. And in any industry facing limits, one civilian's impossible trick still whispers. Challenge tradition, reorganize systems, empower ordinary people, and watch the impossible become routine. As the SS Robert E. Peary made headlines, the ripple effect extended far beyond the Pacific shipyards. Boardrooms in Detroit studied welding innovations, while oil fields in Texas adopted arc-welded pipelines inspired by shipyard practices. Educators re-examined apprenticeship models, questioning the necessity of 4-year training when short, focused courses yielded productivity leaps. And policymakers saw in Kaiser's program a template for mobilizing resources under crisis. But perhaps the most enduring lesson lay in leadership. Kaiser wasn't a shipbuilding luminary. He was a visionary opportunist who saw beyond established boundaries. He granted autonomy to engineers like Clay Bedford, empowered foremen to experiment, and trusted untested workers with critical tasks. That decentralization fueled creativity, accelerated feedback loops, and fostered ownership. Contrast this with traditional hierarchies where directives trickled down, innovations trickled up. At Richmond, ideas flowed freely across ranks, from janitors spotting bottlenecks to engineers refining assembly sequences. This flattened structure proved as revolutionary as prefab modules. Consider the industrial revolutions that followed. In the 1950s, Japanese shipbuilders rebuilt their fleets using modular construction, overtaking American yards by the 1970s. Korean shipyards rose on the same principles, turning Busan into a global shipbuilding capital. Without Richmond's wartime experiment, these ascents might have stalled. Similarly, the automotive industry's shift to platform-based design and just-in-time production echoes Kaiser's synchrony of supply and demand. In healthcare, Kaiser Permanente emerged from shipyard clinics, prepaid, preventive care networks that treated workers holistically. The integration of care, data, and community in medical practice reflected the integrated production lines that moved ship sections from forge to float with minimal friction. All traced back to a wartime necessity: keep the ships coming. Yet it's crucial to remember that this transformation wasn't flawless. Early welding defects caused brittle fractures, and 3 ships snapped in half. Those failures catalyzed improvements in steel composition and welding protocols, underscoring the iterative nature of large-scale innovation. Kaiser's motto, "Perfection is the enemy of sufficient," was tempered by rigorous quality controls. He balanced speed with safety, ensuring that each ship met minimum seaworthiness standards. That equilibrium allowed Liberty ships to survive a 7.4% casualty rate, comparable to merchant fleets built traditionally under threat. And while the vessels weren't elegant, they were effective, a testament to the power of adequacy over perfection when time is the ultimate adversary. The legacy of those wartime yards endures in every container ship, every cruise liner, and every naval vessel built with block construction and automated welding. Modern digital twins and robotic welders are descendants of arduous tasks once performed by hand in California mudflats. We stand on the shoulders of welders and assembly crews who proved that expertise can be concentrated and scaled. Today, as industries confront new challenges, from decarbonizing supply chains to scaling semiconductor fabs, the message resonates. Systemic reimagining can unlock capacities previously deemed impossible. When climate emergencies pressure energy grids, when pandemics shutter production lines, or when complex projects threaten delay, the Kaiser model offers a blueprint. Convene diverse talent, simplify plans, modularize components, and iterate quickly. Ordinary workers, given clear tasks and trust, become extraordinary problem solvers. And leadership that prioritizes learning velocity over error elimination can achieve breakthroughs at unprecedented speed. So when the next crisis looms, be it in manufacturing, healthcare, or digital infrastructure, remember the shipyards where a civilian's impossible trick turned walls of skepticism into launch ramps of possibility. Each prefabricated section, each arc weld, and each daring schedule rewrote the rules of large-scale production. And in doing so, they built more than ships. They built a new narrative of what humans can achieve when technology, management, and belief converge. In that spirit, consider your own domain. Which traditions limit your pace? Which hierarchies hinder idea flow? What incremental gains keep you comfortable but leave breakthrough on the table? Kaiser's innovation wasn't an accident. It was a deliberate dismantling of orthodoxies. And the results weren't simply faster ships. They were a transformed industrial landscape that carried the Allied victory and shaped the post-war world. As the Liberty ships slipped into the water, they bore not just cargo but a manifesto. Constraints are invitations to innovate, and the boundaries we accept today can be the challenges we overcome tomorrow. The narrative of Liberty ship construction culminates in a lesson both urgent and timeless. Mastery lies not in perfection but in purpose. In those mudflats turned megafactory, ordinary people welded their doubts away and built vessels that carried victory across oceans. Yet this was not a dramatized fable. It was a strategic imperative. Each module dropped into place represented tons of cargo, thousands of lives saved, and a strategic advantage no submarine network could erode. Contrast that with conventional doctrine, where safety margins and aesthetic details stalled progress until every rivet gleamed. Kaiser redefined good enough to mean mission accomplished and leveraged it as a competitive edge. As wartime demands peaked, his 7 yards delivered tonnage at rates that outpaced enemy sinkings. 3 ships launched daily, each one testament to streamlined processes and empowered workers. The ubiquity of welding arcs replaced rivet guns, a visual metaphor for progress detonating ancient constraints. Yet beneath the spectacle lay a deeper transformation. Kaiser's simplified drawings stripped away ornamental detail, focusing on dimensions and function. Workers filled in gaps with judgment honed by repetition. This decentralization of design authority accelerated production and nurtured ingenuity. While traditional shipwrights clung to detailed blueprints, every welder and fitter became a micro-innovator, adapting methods to local conditions and optimizing workflows in real time. This culture of adaptive expertise defied the rigid hierarchies of established yards, where deviation was discouraged. In Richmond, rebuke was rare, only results mattered. As ships rolled off the ways at record pace, the Maritime Commission's records shifted from skepticism to admiration. Private correspondence revealed the reluctant acknowledgement. A man with no shipbuilding pedigree had outpaced masters of the craft by redefining competence itself. And in those pages, a blueprint emerged. Industrial revolutions begin when expertise is distributed, not centralized. Post-war, when Kaiser's shipyards shuttered, the knowledge survived. Modular construction and welded hulls became global standards. Schools adopted focused, task-based training. Employers realized that targeted skill acquisition in weeks could match or exceed years-long apprenticeships for specific roles. This recalibration of workforce development fueled the rise of modern vocational training and community colleges. Similarly, supply chain integrations, steel mills next to assembly areas, logistics synchronized with production, laid the groundwork for just-in-time manufacturing. At every turn, Kaiser's wartime solutions reverberated through peacetime industries. Yet perhaps the most human legacy was the democratization of industrial opportunity. Women, African Americans, and immigrants, once excluded from skilled trades, stood side by side welding seams and hoisting sections. They built ships and built careers. Their triumphs shattered guild barriers and seeded the civil rights advancements that followed. When classes disbanded and factories pivoted to consumer goods, these workers carried their expertise into burgeoning industries, automotive, aerospace, electronics, seeding innovation across sectors. The SS John W. Brown and SS Jeremiah O'Brien endure as museum ships, silent guardians of that revolution. Their steel hulls tell a story of improbable achievement, a story that echoes in every modern shipyard and in every ambition that challenges convention. So today, when leaders face bottlenecks, be it vaccine distribution, semiconductor fabrication, or renewable energy deployment, they can look back to Richmond's concrete floors and salvage lessons from wartime ingenuity. Reframe the problem. Treat complex projects as assembly puzzles, not monolithic undertakings. Modularize tasks and train workers for specific repeatability. Encourage decentralized innovation and pit teams in friendly competition. And most importantly, redefine excellence as impactful progress rather than unattainable perfection. The Liberty ships were not masterpieces of naval architecture. They were workhorses of victory. But in their simplicity lay their power. They proved that in the crucible of necessity, speed and adequacy trump pristine craftsmanship. They demonstrated that humans, when trusted and organized, can exceed expectations set by tradition. And they offered an enduring challenge. Wherever constraints seem immovable, Innovation awaits those bold enough to question what impossible truly means. In the final moments of this tale, let us recognize that the greatest legacy of those steel leviathans is not their tonnage or longevity, but the mindset they embodied. A mindset that dares to dismantle orthodoxy, to empower the untrained, and to transform industries in weeks rather than decades. That mindset remains our most precious cargo, one capable of carrying future generations toward horizons currently deemed unreachable. The story of how one civilian's impossible trick remade global shipbuilding serves as a clarion call for every industry facing disruption or crisis. Imagine standing on those Richmond mudflats at dawn, watching cranes lift massive steel modules as arc welders lay bead after bead with practiced precision. Picture boardrooms where executives question age-old doctrines, supply chains rewired to deliver components just in time, and classrooms where students learn to master tiny repeatable tasks rather than broad, decades-long apprenticeships. This was not mere wartime improvisation but the birth of a new industrial ethos, one that prizes modular design, parallel workflows, and rapid capability development. At the heart of this ethos lies a profound human truth. Ordinary individuals, when trained, trusted, and given clear objectives, become extraordinary contributors to a collective mission. In Kaiser's shipyards, secretaries became expert welders, farmers became skilled riggers, and housewives became vital operators of heavy machinery. Their success rewrote assumptions about who could contribute to high-stakes manufacturing and how quickly essential skills could be acquired. As industries worldwide adopted these lessons, vocational schools and technical institutes transformed curriculum, focusing on specific competencies aligned with job needs. Apprenticeships shortened, on-the-job training expanded, labor barriers crumbled. The ripple effects extended into social policy, influencing debates on workforce development, immigration, and inclusivity. Additionally, the integration of supply chains, steel mills positioned adjacent to shipyards, rail networks synchronized with assembly schedules, anticipated modern just-in-time manufacturing and complex global logistics. Automotive plants adopted block construction. Aerospace contractors modularized fuselages. Electronics manufacturers implemented assembly line subunits. In each case, the principle remained constant. Decouple subsystems, optimize them in parallel, and integrate seamlessly for final assembly. Moreover, Kaiser's decentralized leadership model, empowering engineers, foremen, and frontline workers to innovate, foreshadowed agile management frameworks now ubiquitous in software development and corporate strategy. Cross-functional teams, sprint cycles, iterative prototyping, these concepts echo the dynamic environment of the Liberty shipyards. By flattening hierarchies and celebrating rapid learning, Kaiser unleashed continuous improvement at a pace unmatched by traditional command and control structures. On a strategic level, governments and militaries recognized the power of industrial agility. Post-war defense procurement embraced modular contracts and fixed-price bids, while emergency response agencies structured rapid deployment teams akin to shipyard task forces. The lessons of Richmond's experiments even influenced space exploration logistics, where prefabricated habitats and standardized modules enable faster mission assembly. Yet the most enduring legacy may be the mindset itself. When confronting seemingly insurmountable challenges, whether pandemics, climate change, or technological disruption, the question becomes not can we do this, but how can we reorganize our processes, empower our people, and redefine capability? The Liberty Ship program answered that question under existential duress and delivered 2,710 vessels in 4 years. It taught us that constraints are not barriers but catalysts for innovation. As modern leaders chart the course through uncertainty, they can draw inspiration from those welders, crane operators, and managers who built ships in days, not months. The creed they embodied, question tradition, simplify complexity, train rapidly, and embrace parallelism, offers a blueprint for breakthroughs in any domain. And so, the legacy of those steel leviathans continues to guide us. Their silent testimony rests not only in preserved museum ships, but in every factory line, training program, and project plan that values speed, adequacy, and the power of collective ingenuity. Challenges us to ask, where do our own traditions limit our progress? Which processes like rivets and sequential workflows can be replaced by more flexible, modular approaches, whose expertise lies untapped in our organizations, waiting to be unleashed. The answers lie in the same principles that made Liberty ships appear every 4 days instead of 230. They remind us that impossible is merely untried, and that revolutionary improvements often emerge from those unbound by convention. As we face the next horizon, whether building sustainable energy infrastructure, scaling semiconductor fabrication, or responding to global crises, let us carry forward the spirit of Kaiser's transformation. Because, like those Liberty ships, the greatest cargo we can launch into the future is belief. Belief that ordinary people, organized with vision and urgency, can accomplish the extraordinary. In the final 15 seconds, don't forget to subscribe for more deep dives into history's greatest innovations. Comment with your thoughts on revolutionary manufacturing, and hit the bell to stay notified of our next episode.